Oh, and I will absolutely post it if somebody does something stupid. I hope that it's me that does something stupid. So, Module 1, Lesson 17, Scale Factors. The first thing that we really actually need to define is scale factor. I am going to abbreviate scale factors simply for my well-being as SF. And if you're like, Mr. H, why? Because I can. And I've done this now. This is the 4th time that I've written these notes. So I'm tired of writing scale factors. A scale factor is a ratio. And we're going to pause for a second. Because lesson 1, module 1, we talked about a ratio. So everybody has been taught what a ratio is. So I should see lots of hands going up. What is a ratio? And Bryson's just waving at me. A little creepy, man. A little creepy. Hands. What is a ratio? I need more than 2 hands in Bryson's creepy wave. Hey, if you need to, go back in your notes. Go to lesson 1. Tell me what a ratio is. I'm going to give everybody about 30 seconds. Ava just got really excited. She's like, I found it! Yes! Reed's not as excited. Reed's just hoping I don't call out. You're not even part of the class, Miss Houck. Stop it. Kenzie, go. A comparison of 2 numbers. Okay? A scale factor is a ratio. Then we're going to have a specific way of comparing the 2 numbers, which we know is a constant. So it's a ratio or a constant of 2 images. And there is an equation to find scale factor. And if you're like, hey, there's a star next to it. Yeah, there is. You know why? Because stars are important. Just like all of you. So, this is going to look familiar because you've seen it already. It's the reduction or the enlargement. Getting divided by the original. Okay? If you notice, it's already over on the board. You know why? Because we've done this already. We did this yesterday, except we just called it the constant. Okay? Now, are there more geometric terms for the original and the reduction and enlargement? Yeah, it's called a pre-image, it's called an image, or a prime image. Right now, we're just sticking with the basics. Okay? We're not getting into full-hearted geometry yet. So we've got a reduction or enlargement and an original. So what does that scale factor tell me? So we are going to how to use a scale factor to determine if it's an enlargement or reduction. Now, I have some horrible news for you guys. So as you know, there's a lot going on in my life right now. My wife's in Phoenix, so I'm doing the single dad stuff. Cole and I are having a blast. He spent an hour last night. It was great. Oh man, he spent an hour last night screaming on the floor saying, "Mommy!" And he wouldn't let me pick him up because he tried to bite me and kick me. And I'm like, let's go downstairs and play. And then he'd crumble to the floor and cry. Let's go outside and play. And then he'd crumble to the floor and cry. So he screamed for an hour. And he's just like, "No, Mommy!" And I'm like, "Mommy's not home, man. Like, I don't know what to do." So that was fun. My condo's getting fixed. The flooring company is finally in there, actually putting down the flooring, which is great. Now, why am I saying this? Because today is one of my favorite days of the year. And when I taught algebra, it was amazing. Because usually we were just getting started in like multi-step equations, and every variable that I had was R. Because I forgot. Usually I come dressed up, and I've got a rubber ducky that I tape to my shoulder. And I've got a hook. Because today's National Talk Like a Pirate Day. And Addie remembers National Talk Like a Pirate Day last year because I truly talked like a pirate usually for the entire day. And I make bad pirate jokes, I'm like, arr, and I'm like, but I forgot about that. And I can't start now. And that disappoints me because I just realized it in Orange Shine. Because there's so many fun R words like enrichment that I could talk like a pirate and it bothers me. So you guys lost out on National Talk Like a Pirate Day. And I'm sad. Okay, back to this. How to use a scale factor to determine if it's an enlargement or a reduction. Well, let's go back to our first example. The very first thing we did. Was that sticker, which was proportional, an enlargement or a reduction, and why? And I should see everybody's hand. The example that we did was an enlargement or a reduction, and why, Gabe?
Bigger.
Yeah, it was an enlargement because it was bigger. So, when we're talking about scale factors, one more time, show me with fingers, what was the scale factor for that example? Mike is like, no. Like you looked at your hand, you're like, no, that's not right. It is 2. Okay? So the scale factor was 2 to 1, which means the enlargement was 2 times bigger than the original. Do we agree with that? Yeah? Nods? Yeah, okay. For it to be an enlargement, the scale factor must be something. What does the scale factor have to be in order for it to be an enlargement? And I'm looking for 2 mathematical words and a number. What do we think? So here's one of our scale factors. It was 2 over 1. Keely, what do you think? Not quite. Good guess. There's no words coming out of your mouth. Are you all right? Good? Okay. Tippy.
Greater than 1.
There you go. So the scale factor must be greater than 1. Okay, so some examples. Well, we've already got a scale factor. We know that our scale factor was a 2, which was really 2 over 1. It's 2 times bigger. So another example, well, what about 3 over 2? That's greater than 1, because if I simplify that and I divide it out, that's 1 5/10. What about 93/77? Is that good? Yeah. Somebody in my first hour said, so wait, Mr. H, if it's an improper fraction or if I can change it to a mixed number, yeah, absolutely. So if the scale factor is greater than 1, it will have to be an enlargement. It will get bigger. Everybody still with me? Okay, common sense. Some of us have it, some of us are still working on it. Not going to name names on that. Ms. Hauk? Yep, perfect. No, perfect. You answered that question perfectly. That's what I needed. What? Yeah, exactly. Good. Let's see. Okay. And we've caught up. Okay. Can we see that yet? Kind of, maybe. Okay. So the second thing is the reduction. Common sense says you should be able to fill in the definition without me having to tell you. If an enlargement said the scale factor must be greater than 1, every hand should be able to go up and say, I know the definition for the second one. So this is where I'm going to say, okay, every hand, yay! Ava again got really excited. It was like, call on me. Go, Ava.
Must be less than 1.
What must be less than 1? Okay, so the scale factor must be less than 1. So again, examples. The scale factor could equal 1/2. The scale factor could equal 3/7. The scale factor could equal 1/20. Anything less than 1 will mean that the end result going from the original to the next figure will be smaller, which means it is a reduction. Questions so far? Gonna work? Yeah, it will. Okay, so now what I want you to do is go into your packet. You're going to example 3. It's on the 3rd page. It's the only page that has just 2 paragraphs. So flip it over until you get to the third page where there's just 2 paragraphs. It's the one that says example 3. Okay, so let's read it. I would have a pencil in my hand because I'm going to put some emphasis on some of the words. Have emphasis, guys. Circle, underline, do what you need to do. Your family recently had a family portrait taken. Your aunt asked you to take a picture of the portrait using your phone and send it to her. That right there is all extraneous information. None of that matters. Extraneous, extra, cool. If the original portrait is 3 feet by 3 feet, if the original portrait is 3 feet by 3 feet, and the scale factor is 1/18, draw the scale drawing that would be the size of the portrait on your phone. So, this told us a couple things. First, we have an original picture. And we know a scale factor. That's pretty much all it told me. Okay? So it says it's 3 feet by 3 feet. The first thing that I know by that is it's going to be a square. So when I draw this, I'm going to draw my nice big old square.
That's a rectangle.
No, it's going to be a square.
That's a rectangle. Rectangle.
Gotta trust and believe. So, if it's 3 feet by 3 feet, that means length by width. And as soon as I put notations on there, it doesn't matter what the geometric figure looks like, you gotta go with what's written. So now I have my square of 3 foot by 3 foot. Presley, what is my scale factor? What's it say in that problem? There's a fraction in there. 1/18. Okay. So now I've got all the pertinent information. For me to solve this and be able to draw the next figure, I need to figure out, well, is it an enlargement or is it a reduction? Grace, will it be an enlargement or a reduction based off of the scale factor? How do you know it's going to be a reduction? Because it's less than 1. Okay, so it's going to be a reduction. I know that if I'm reducing 3 feet by 1/18, I'm not going to be able to do that because I don't know what 3/18 of a foot is. So there's a conversion that I'm going to have to do. What should I change these feet into to help me work a little bit easier? Mason? Fraction's a good guess. Inches. We're going to change them into inches. And I know that 1 foot is equal to 12 inches. So I'm telling you that if you're reducing feet by a large number, such as 1/18, you should change them into inches. So how am I going to change this 3 feet into inches? Multiply it by 12. 3 times 12 is going to give me 36 inches. This is going to give me 36 inches. Okay. 3 times is the charm. I'm going to say this 3 times. I hope that it sinks in. To go from the original to the reduction, we take the original's length and we multiply by the scale factor. To go from the original to the reduction, we take the original's length, we multiply by the scale factor. 3rd time's the charm, right? Right?
That's true.
I know, that's why I have 2 fingers on. To go from the original to the reduction, we take the original length, we multiply by the scale factor, and we get the reduction's length. So, because the length and the width are the same, I'm going to take my 36. I'm going to multiply it by 1/18. Can I do this the way that it's written? Okay, so hands. What do I need to do in order to get this going well, Reed?
Make your 36 a fraction.
Okay, make it a fraction.
Yeah. Put it over 1.
So the denominator will be 1. Why? Why does that work?
Pretty much.
Okay.
Okay. So pretty much, it's that way. There's 36 ones. So 36 ones.
Okay, I like what you're saying. I like what you're saying. There are 36 ones. Can somebody give me a little bit more mathematical understanding of why does 36 divided by 1 work? Scott?
It's a whole number, and by 36 by 1 is just 36.
Yeah. Because 36 is a whole number, this stays as 36 when I make it divisible by 1. 36 divided by 1 is still 36. So I multiply across, gives me 36 divided by 18. Somebody help me simplify. 36 divided by 18 leaves me with, Keely, 2 over 1, or just 2. Since we're actually talking about some kind of unit, it will be 2 what? Inches. So now I can draw my new figure. Because both sides are the same, I am left with 2 inches by 2 inches. Questions, concerns, problemos? Okay, back to group work.